Hello friends, now we are going to talk about the another kind of the effects, that is non-ideal effects in the transistor. Okay, so one of the effect is nothing but the band gap narrowing. Okay, so this effect comes into the picture when we are trying to understand that the amplification factor. Okay, so in addition to the amplification factor, the factors contributing to it is nothing but the Gamel number, that is already we have seen it. Okay, so when we are trying to calculate this amplification factor, there is another important and the dominant factor besides the Gamel number, that is NB dash. Okay, that is nothing but the emitter doping concentration, that is Ne. Okay, so now if we want to improve the this amplification factor, that is HFE. Okay, so the emitter has to be heavily doped, okay, than the base, so that the carrier concentration in the emitter is very large than the carrier concentration in the base. So now as the emitter doping becomes very high, okay, emitter doping becomes very high, we have to consider the band gap narrowing effect. Okay, so when the band gap narrowing effect comes into the picture, whenever there is a emitter concentration is very high, or doping is high as compared to the base. Okay, in addition with another effect is nothing but the OJ effect. Okay, so OJ effect is also there, but in addition to that, this effect has to be also considered. So on both this effect, OJ effect as well as the band gap narrowing effect, actually causes the reduction of the HFE. Okay, so now the band gap narrowing effect in the heavily doped silicon has been studied based on the, what we can say is, on the broadening of the both the conduction band and the valence band. So the both valence band as well as the conduction band both are getting broadening. So the empirically the band gap reduction delta Eg can be expressed as delta Eg is equal to 18.7 ln n upon 7 into 10 raised to 17, okay, in millielectron volt it is expressed. So this is something like a experimental observation in particular material. Okay, now here n is obviously has to be the greater than this value, so the n is always greater than 7 into 10 raised to 17 per cc. Okay, so now the experimental results, obviously the from the various data is plotted, but that is not, we are not interested in it. Okay, so and obviously though it is in a good agreement. Okay, so the, now here we are trying to understand that the intrinsic carrier concentration in the emitter, okay, E stands for the emitter. Okay, so NIE square is equal to NC NV. So the this is the conduction band concentration, valence band concentration, exponential of minus E minus Eg minus delta Eg by kT, which can be given to be the Ni square exponential of this term, exponential of the delta Eg by kT. So here this delta Eg is what we can call it as the increase in the, or increase in the band gap. Okay, so Ni is nothing but the Ni here is nothing but the intrinsic carrier density without band gap narrowing effect. So the now so the minority carrier concentrations in the emitter becomes minority carriers in the emitter, because we are considering here the NPN transistor, so the minority carriers are the holes. So the minority carrier concentration in the emitter is given to be the PNOE. E stands for again emitter is equal to NIE square by NE is equal to Ni square upon Ne exponential of delta Eg by kT. Okay, so now this delta, so this effect is nothing but the what we can trying to understand here is nothing but the net effect is increased minority carrier concentration in the emitter. Okay, so the common It is common then to account for this band gap reduction by reduced effective emitter doping. Okay, reduced effective uh, emitter doping can be given as, okay, so the effective doping in the emitter is NEF is equal to NE exponential of minus delta Ag by KT. This negative sign stands for the reduction in the effective emitter doping. Okay. Now, so in any case, if we are just trying to understand that the net result is what we can say is the net result is an increased hole diffusion current. Okay, increased hole diffusion current from the base to the emitter, and the current gain is reduced according to this equation. Okay, so now, so the HFE can be given or is given or the proportional to the NPO upon NPO PNOE, which is also the proportional to the exponential of the minus delta Ag by KT. So this is all comes under the band gap narrowing effect. So while considering the band gap narrowing effect, do remember that the emitter carrier concentration has to be very greater than the base carrier concentration, and in addition with this, the obviously there is a existence of the OJ effect.